All right, concept development. This is Engage New York, Module 2, Lesson 12. Remember what our objective is today. Our objective is to multiply decimal fraction by a single-digit whole number using estimation to confirm the placement of the decimal point. So we're going to kind of continue with what we were doing yesterday. So we're going to start with a whole number and then move to a decimal that has one number behind the decimal. And then we're going to move to another that has two numbers behind the decimal. So we're kind of building, if you will. All right, so remember, you're drawing out what I'm drawing out right now. So let's start with an area model. And the area model can be kind of small on this one because we're going to have 30 plus 1. And then we're just going to multiply that by 4. So 30 times 4 is 120. 1 times 4 is 4. And so that ends up giving us a total of 124. Now let's take it to the next level. And what have we been doing? We've been getting rid of our decimals. So it's like multiplying by 10, right? Over here, it's going to be like multiplying by 100 to get rid of that decimal, correct? All right, so now let's go ahead and draw another. And we're going to have 30 plus 1, but now we're going to write the word tenths. And now we're going to multiply by 4 again. 30 times 4 is 120. 1 times 4 is 4. Oh, we're going to have the same answer. But wait a minute. If I multiplied by 10 to get rid of the decimal, when I come down here, I have to divide by 10 to put that decimal back. Okay? Now, let's go to problem 3. We're going to do the same thing again. But instead of multiplying by 10, you're going to multiply by 100 to get rid of that decimal. And then you're going to have 30 plus 1 times 4. Now we're going to have 30 times 4 is 120. And 1 times 4 is 4. And we end up with 124 again. But the difference is now instead of dividing back by 10, we're going to divide by 100, and we're going to move our decimal point back in. Okay, how are you doing so far? The digits are the same, but remember your comma, the values of the numbers are different. So the numbers are the same, but they have different values. That's what makes them the same, and that's what makes them different, right? All right, so let's go on to problem 4, 5, and 6. So we are going to convert 5.1 to tenths in order to make a whole number. So this is what we're doing. We are convert numbers or decimal, let's say decimal numbers, to whole numbers. So that's what we're doing here. We're converting decimal numbers to whole numbers. And we're converting them by using multiplication. Yes? So let's go ahead and let's convert 5.1 to tenths. Well, in order to make for a whole number. That's what we're doing here. So let's do it. So we are going 5.1 times 10 equals 51 tenths. That's what we're doing. So now we just are working with a whole number. We don't have a decimal in here now, right? So now let's just multiply using standard algorithm. Let's go 551 times 6, and we end up with 306. Now, we have 306 tenths though, friends. We have 306 tenths. So, in order to go and put that decimal back in, because remember, we converted it to get rid of it, now we have to divide by 10 to put it back. So our answer is 330.6. Yes? Okay. Now, let's go on. Let's keep going. So, if I'm converting this and getting rid of the decimal, I'm going to go 11.4 times 10, which is going to give me 114 tenths times 4. So now I can go 114 tenths times 4, and I'm going to get 456. But because I multiplied by 10 to get rid of the decimal, now I'm going to divide by 10 to put the decimal back. And I end up with 45.6. That is my answer. Any questions? All right, moving on to problem 6. So let's convert 7.8 times 10 is 78 tenths. Now, you guys know the reason why I'm writing tenths is because we only have a tenth here, right? We're only getting rid of a tenth. So 78 times 10 is so easy, right? Oh, wait, it's not times 10. Sorry. 70. Let me rewrite that. 78 times 3. Sorry. 8 times 3 is 24. 21, 22, 23. Now, because I multiplied to get rid of the decimal, I need to now divide by 10 to put that decimal back in. And then my answer is 23.4. All right. Moving on to problem 7. Problem 7, 8, and 9. All right, so now we're going to do the same thing, but guess what? How many numbers do we have behind the decimal this time? Now, instead of converting it to tenths, we're going to convert it to hundreds. So 3.12 times 100 is going to give us 312 now times 4. So go ahead, 312 times 4. Now, if I multiplied by 100 to get rid of the decimal, I need to divide by 100 to put the decimal back. And I get 12.48. All right, now, so if I said 1,248, is that the right answer? No, because you have to divide by 100 to put that decimal point back. All right, so you could do you could do this using area model if you want. You could go 300 plus 10 plus 2 times 4. do your partial products, add it up, and you'd end up with, and then you'd have to go put your decimal back to make it correct. All right, you guys, problems 8 and 9, I'm going to ask that you do it yourself. Then we will come back to debrief. All right, so you should have multiplied to get rid of the decimal. You did standard algorithm, put it back. Multiplied by 100 to get rid of the decimal, multiplied, divided back by 100 to put it back. All right, so now it's time for problem set. Choose the reasonable product for each expression. Explain your reasoning in the spaces below using words, pictures, or numbers. You guys, you have to get good at this. You have to get good at explaining. So let me give you an example of what I expect. All right, so 2.5 times 4 is essentially 2.5 plus 2.5 plus 2.5 plus 2.5, right? So 2.5, let's go like this. 2.5 plus 2.5 is really 5 plus 5. So that would equal 10. So I know that 2.5 times 4 would equal 100 tenths also. And 100 tenths would be 10. So do you see how I reasoned this out? I showed you how I was able to figure out what this would be equal to. Well, I reasoned it using numbers and some words. So you're showing me what you think is a reasonable answer by showing me how you would solve this. How would you solve this in order to check? Number one, here, there are two numbers behind the decimal. So we know, number one, our product would have to have two numbers behind the decimal. So do you see how I'm trying to reason out the answer? I'm thinking and using what I know about multiplication and multiplication with decimals to try to reason out, what makes sense? There are three numbers behind the decimal, so I know my answer has to have at least three numbers behind the decimal, number one. So you're going to solve this and circle it and then tell me your reasoning. Make sure to explain your reasoning. On the back, just quickly turn to the back so I can explain the word problems. Pedro is building a spice rack with 4 shelves. Each shelf is 0.5 meters long. At the hardware store, Pedro finds that he can only buy the shelving in whole meters. So that means you have to round up when you get your answer because they're not going to let you buy a part of a meter. It's like the school bus, remember? Okay. Then Marcel rides his bike to school and back. So he goes from home to school and then back. So do you see how I draw pictures to try to understand what I'm actually solving for? Draw a picture, draw it out. And then the Poetry Club had its first bake sale and made this amount of money. Okay, this problem, I don't think it's going to be that hard. I think you're going to be okay. So go ahead and try it, and then we'll come back and debrief.